Welcome to Sarah Drake's Lounge, Australia, the June edition, June 2023. A couple updates. If you guys are a member of Sarah, you should have gotten the link for the new Sarah Journal, the May-June version, and your Steve Olney is actually the cover photo of that, and he's doing pulsar glitches. We've got the Eastern Conference. You can sign up for that or go to it in Green Bank on the 20th, 22nd of August. And also we have elections for officers. Currently, we're going to have the treasurer and secretary from the officers, and then we'll have two directors and two directors at large. The directors at large positions were people who are not required to go to the meeting in person. That's why they were set that up. And the directors are required to go to the meeting in person. I think we're trying to change the bylaws that there is no difference. And the Zoom meetings, we've been doing Zoom meetings for the last 3 years. And I don't think there's any real requirement, legal requirement for all the directors to show up physically anymore. But it's still in the bylaws. So right now, that's the difference between a director and a director at large. As the president, I use the directors at large considerably. I call them all the time. At least I look for advice. They do review the journal before I send it out to the membership. They catch a lot of good things. I mean, a lot of my editorial editors errors they've caught many times, and they help just sort of as a peer review kind of approach. Then any large financial obligations changing in like how much we can. They really need to approve any large expenditures, like how much we give to the grant committee and things like that. And any large issues. For example, right now we're looking at insurance. If we need insurance, and they'd have to vote on doing insurance, stuff like that. So we really do use the directors quite a bit, and they are significant advisors to the. We have 4 officers, and they really approve everything. All the conference, large expenditures or large decisions that will go through the board. So if you are interested in being on the board, it's a very good way to, understand what a multinational group like ours does. And so right now we don't have any issue with anybody from any country being on the board. I don't think that's even in the bylaws. So even though sort of U.S. based, I don't think there's, right now Wolfgang's on the board. He's Germany. I don't think we have anybody else that's from a different country, but there's no stipulation that you have to be from U.S. to do this. Let's see. You probably saw if the annual dues are coming up. Brian is our treasurer. He sent out a notice for annual dues, and really she's trying to break it up because a lot of times it's set up for August, which is right during the time of the Eastern Conference. So we set out a June version. Anybody expiring in June, send in your dues, so. Then he'll probably send one out next month, but it won't be as you won't get this massive reply because he's splitting it up a little bit. So, which is really good. We are actively looking for a treasurer. The treasurer position is probably the one who interacts the most. even though they're not operating the store, they're doing the financials. They get the PayPal notices and verify that the funding has come through for PayPal for any store item being bought. They handle all the membership renewals and all the conference renewals or conference people who sign up for conferences. So they're basically handling all any money issue. So even though it's not hard, you're interacting a lot. So after doing that, I'm trying to get people to, anybody that wants to take that job on, if you got any financial expertise, that'd be great. Let's see. We do have Ted today that's going to show, part of our shoes survey. He's got a way to distribute the data. They'll show that as soon as we get a break. And okay, that's all I got. Paul, what do you got?
Yeah, I need a little more time. I'm enhancing it. Carry on.
That's fine. Go ahead, Paul. It's all yours.
Yeah, hi everyone. Regarding the elections and also the conference, I was looking at the time differences. I think we're 14 hours difference, and that is tricky, given the Eastern Conference. Richard, I presume sessions will be recorded, as they have been.
Yeah. Everything will be recorded and probably broken up into different separate lectures and put on the YouTube channel.
Yeah, so I think, well, from our end, then it's worth registering for the Eastern Conference, and then that gives you access to the recordings later. I think from memory, I think I called in and joined the Zoom live a little bit last year, but a lot of it takes place during our night, so we'll see what happens. As far as the elections are concerned, I think it would be quite good to have Southern Hemisphere representation.
That'd be a great idea.
So if anybody from this end is thinking about that. The other one that I wondered about, whether there was some scope within that, or just within the organization in general, for an education coordinator that would concentrate on schools.
Well, that's the two committee chairs that we are also missing is the membership chair and the education chair.
Yeah.
So I'm looking, anybody wants to do that, that'd be great.
So on the education side, is that higher education, tertiary, as well as, so that's the whole range?
That's the whole range. Whatever you want to make it, bring your own skills and your own ideas to that, and just run with it.
Yeah.
And Paul, I am working the final schedule for the Eastern Conference, and
Yep.
we have carved out 2 presentation slots for you or anybody from Australia, New Zealand who would like to present. If you would like to, all you need to know is let us know so we can firm up those time slots.
Do you have the times, Jay, on you? Do you know where you put them?
We'll work around your availability. I'm not sure if middle of the U.S. mornings or afternoon times would work better for you, but we can move everything around on the schedule with the exception of elections and our keynote speaker. But everything else is flexible and will work based on your convenience.
Yeah. As I say, I think you're -4 from UTC and we're +10. So I think 14, we'd need to work on that basis. Let me have a look at, I saw the schedule in the journal. So I usually do a sort of a little table and convert each of the times, and then we'll see what works for either an evening slot or a morning slot.
Okay, and you are correct. West Virginia, where the conference is UTC -4 this time of year.
Yeah, and I was pleased to see reference to the UTC time this time. Sometimes it gets forgotten, and we have to jump on some piece of technology and work out exactly where you are. But yeah, UTC is a good reference for us all. Obviously, that's why it was established.
Yes, and the final schedule will have all events shown in local time as well as UTC.
Excellent, great stuff. Well, I think perhaps Steve, are you able to give us where are you? I can't even see you at the moment. Oh, are you there? Quick rundown. I know we're still having issues with our dish, as many of you would know from last time. The worm screw that was responsible for the tilt was playing up, and that's quite a saga. We probably don't have time for the full story, but a quick update, Steve, would be good.
I'm desperately trying to get my act together and transfer a few files from one computer to another. So can you give me a few more minutes, Paul?
Yeah, okay. Yeah, well, I'm aware of Ted's work on trying to pull data from both hemispheres. So if we can get to the stage where we can supply data, then that's going to be a really good thing. I think it's we've made some progress in replacing that worm drive, but I think there are two issues. One is obviously the cost. So we have to find a solution that is actually affordable by the Astronomical Society of Victoria. And the other one is to try and future-proof it in some way so that we don't end up in a year's time or 2 years' time back in the same situation where, so we need, I think they're talking about weatherproofing it and a particular style of worm screw that will be a bit more forgiving in terms of wear and tear. I think that's probably where we're up to. As far as I'm concerned, I've not done anything significant, so I have no report at this stage because it's end of term and it's been exams and all the hoo-ha that goes with the end of term. So that's my excuse.
I think I'm ready, Paul.
Yep, I keep having to go to work and do what I'm trying to do. So Steve,
I'll spare you the agony of having to pad things out for a few minutes.
Yep.
Thanks for that. Look, good morning, gentlemen. On behalf of the radio astronomy section of the ASV, and in the absence of Phil Costigan, who I thought was going to be on this morning, I can bring you up to date with our progress on the restoration and maintenance schedule of our radio telescope at Heathcote. I'll share this image. Is everybody seeing that okay? It's a phosphor bronze worm gear. Is that appearing on the screen all right?
Yes.
Oh, good. Well, this is the thing that's worn out, and it's not that external worm drive. That appears to be really quite good, in fact, but that's not under a very severe load. That's the drive. There's a shaft with the worm gear on it, connected to a motor, of course, and a gearbox, and that drives the rotation of that gear. But where all the stresses and strains comes from is this thread through the middle. The telescope and the jack screw that passes through this thread weighs up to over a ton. So, and it's balanced. It gets to about 45 degrees as tilt, and then it's equally balanced. But either side of that balance point, all of that mass of the dish is pushing down through that thread. So we didn't have the jack screw unfortunately in a situation where it was being protected from the weather very well. And the result of that is that it was getting wind and rain and dust and muck and everything like that, passing into the jack screw and down through that sleeve thread. And over a few years of use, it's finally worn out. And the thread is an Acme thread, an Imperial Acme thread, 2 3/4 inch diameter, with a 2 threads per inch, and special sort of a trapezoidal profile. But there's a couple of options for us to proceed with, and we're going down the path of both of them at the moment. One of them is to get quotations to completely replace the whole gear, which in the long term, that's probably going to be necessary. So we've done a technical drawing of this part because one didn't exist. So we've measured it up thoroughly and did a proper CAD drawing, which we can then communicate around to various vendors who can look at. They'll also have the part in hand and all the mating parts. We're going to have like a package of items that we hand to a supplier and say, can you manufacture one of these? And they'll have a technical drawing. They'll have all the parts with them, including a section of the thread that goes down through that worm gear, because that's pretty important to match the threads up. So we're going around to various suppliers at the moment. Some of them have been approached already and they declined the work because they're already too busy, they say. Others have given indicative quotations of several thousand Australian dollars. And there's another path we can approach, which one of the club members is in fact a mechanical engineer, and he's got his own workshop. Even though he's retired, he's kept all of his lathes and his machines to use for various purposes, and he has used them many times over the years. And he was part of the team that actually did some construction of the radio telescope itself, some of the top plates that move and the hinge joints. He did quite a bit of that fabrication, so he's very familiar with our telescope. And he's offered to repair that gear. He's offered to machine out the internal thread that's worn and put in another sleeve with a new thread on it. And to do that, you need a billet of phosphor bronze of the same material, and get a sufficient of it that you could actually make two. So you could have a spare inner sleeve. So when we do wear out another one, you could probably swap it out, and that could give us a life of 5 to 10 years with the two spare inner sleeve threads. It might take a much longer time to wear out that worm drive gear. So we're not entirely sure how long these things will last if they're maintained properly, maybe many, many decades. But we need to anticipate the possibility of that whole gear being replaced because it's integral in the design. So what we did was to have that inner thread sample of that available. We were at Heathcote property not that long ago and collected some more parts for that purpose. And I've got a little video to show you guys that you might be interested in seeing. Nice sparks and so forth flying on the screen. It's always good to see this kind of stuff. I've just got to find an application that will play it. Open with QuickTime, that'll do it. Let's see what that does.
Too many computers, Steve.
Oh, it won't play it. It's not playing it. Just a moment. I've got to find an application that will open this little video player. What about this one? It was captured on my mobile phone, so therefore it's an MPEG-4 format. So I had to find a player that would play it. All right, I'm ready to go. So let me just do a couple of adjustments here, then I can share it on the screen with you guys. So share video with sound. So there'll be nice sound of machine works and so forth. So let's go. So on the screen, you should see a blank screen, and I'll play the video. There we go.
Yeah, that's okay.
So that's the jack screw. It's removed from the telescope, ready for preparation and cutting. We measured off 150 millimeters of one end of it, the lower end of the jack screw, which was a spare length, not required actually. Excellent. Nice to see sparks and metal fly everywhere. So that was just a short section, 150 millimeter long. That's the matching thread for inside that worm drive gear. Very important to have all these parts for whoever's going to do the work. And as I say, one of our members, Greg Walton, he's offered to do it free of charge. We have to pay for this billet of phosphor bronze that will do the replacement sleeve. And enough to do two inner sleeves is going to cost us 900 Australian dollars, which is not a small price. So that's the mechanical side of our radio telescope. That looks like it could still be perhaps into the late spring before we see that mechanically reassembled. In the meantime, I've been doing quite a bit of work with the neutral hydrogen receiver. The reboxing process, I don't know if we've talked about this on the SARA meetings before, have we, Paul? Where we've taken...
I think we talked about the possibly the temperature control side of things.
Yes, the radio astronomy supplies, which is the US company we bought our receiver from, they had a 19-inch rack for the front end and then an external low noise amplifier. So after a really good look at that whole concept, I think I've talked about this in the past, I've decided to repackage it all. So the front end circuit board is now inside a die-cast box, which is packed with foam around that, and then that's inside a plastic box. And then there's a Peltier cell cooling that front end unit on its own as a more contained sealed unit. That reboxing is complete and retesting of that front end is complete, so that all works. I've started doing some thermal evaluation of the Peltier cell and how that all functions. The front end LNA is being repackaged into its another plastic box, which will also be surrounded by foam packing for thermal insulation, and that'll have its own independent Peltier cell to cool just the low noise amplifier. We finally found a suitable switch that would switch between the feed horn, the antenna, and a reference noise source. And the noise source we did obtain from radio astronomy supplies as well. So, and that seems to be really quite stable, thermally stable. I've done a number of tests on that noise source. So that's going to be our gold standard. When we switch between the antenna and this noise source, we can calibrate out a lot of the variations anyway. But I did a lot of experiments on this antenna switch. I looked at some solid state ones, and I got a couple of items off eBay, which didn't work very well. There was like 1 dB insertion loss. The best I could ever get it down to was half a dB or so. Wasn't good enough for my way of thinking, but I found a supplier in Australia that provided a little relay, RF relay switch. I know electromechanical solutions are not always the best, but this turned out to be really, really low insertion loss, 0.2 dB or so. So that's now in the circuit. So the signal, very short length of low loss cable, LMR 400 cable from the feed horn. It's only about 200 millimeters long. And again, you're talking about 0.1 dB loss or so, 200 millimeters long into this relay. Then that can switch between the antenna low noise amplifier is right on the end of that relay, and the other end of the switch is across to a noise source. So I haven't done electrical testing of that, and we've got to build it mechanically to do the thermal evaluation. So that's the progress on that. I'm going to be behind the 8-ball if I don't have this finished before the dish is ready. So I certainly have an incentive to get all of this receiver side of it ready for when it's to go back onto the telescope itself. But I'm pretty confident we'll be in a very good position to do that. We had a piece of electronics up there, a microprocessor, microcontroller, the Arduino Nano, in its own die-cast box. We previously had that as a status monitor to monitor temperatures and fan speeds and things like that. So that required an expansion of that electronic circuit. We've added extra temperature sensor probes, and because we've now got a fan system independently cooling the low noise amplifier and another fan system cooling the front end with their independent Peltier cells. So there's 2 fans to measure. So that was expanded in this status monitor. And I'm using platinum temperature sensor probes, 100 ohm platinum temperature sensor, which is accurate to within 0.1 degree. So we've got some pretty precise ways of evaluating what's going on inside the whole receiver system. And that'll also help us in calibration as we go forward and get this thing to work, particularly with its noise source. I do anticipate we'll never eliminate entirely the potential of temperature stability. We may succeed in getting the low noise amplifier to be pretty stable within a few degrees, but I think the front end, which is a much larger mass, once it gets up to those ambient temperatures of 40 degrees or so at Heathcote, I think we'll lose control of the temperature stability. We just don't have enough power to pump in through that Peltier cell to keep it totally stable. But that's where this noise reference will get us out of trouble. We'll have something to calibrate against. And yeah, so that's the progress as far as I can say, Paul. Things are happening in train. It's nothing standing still. It's moving bit by bit each time. And I'm certainly hoping in the spring we'll have our receiver up and running again.
Good questions.
Really good stuff. There are 2 or 3 points I would make in some of that. One is for Ted's data collection. I think calibration is going to be really important. And it sounds like, Steve, we're heading in the right direction there.
Oh, look, I'm an engineer, and I don't believe that we should do any of this survey work of our southern skies for neutral hydrogen, or anything for that matter, maybe a pulsar even. We shouldn't do it unless we know what the numbers mean, and we can sort of say that we're honest about this measurement. And we will do repetition too. I believe if once we get a scanning going, and a lot of that will have it as automated processes. We've got another guy who joined the team 6 months ago, Dr. Tim Davis. He's also a professor, and he's excellent in writing software. So he's really keen on getting involved in our project at Heathcote as well. And he's got this very clear mind of how we can automate the process of data collection and storage. And he's certainly going in the right direction with us, so that whatever we do collect is a meaningful result. And once we automate it, we can start scanning the sky, go to sleep. Next day, there's another part of the mosaic worked out, and we can start evaluating that data straight away. But I would think over a 12-month cycle, we might start again and just keep building up the precision of that measurement over time.
Yeah. So that's definite progress there. The second point, Steve, you say you're an engineer. I'm a physicist, so I don't understand any of this stuff. I leave it to you. Leave it to you, engineers. I regularly Zoom with my friends from university in the UK from 50 years ago, and most of us are physicists and a couple are engineers, and you can imagine there's some exchange of views between the physicists and the engineers on there. But yeah, we need engineers, but we need physicists as well. So things like
Absolutely.
Working out how a Peltier cell works would be of interest, and that fits in with the education component of SARA. You know, if we, I was thinking perhaps Steve might be able to forward you a report which would go in the journal, and we might pick up on some of the physics underlying the engineering side, and that might be of interest to the readers and to SARA members generally.
Yeah, you guys are welcome to submit all of this, even from an engineering point of view. If you put some of that in an article, even a short article, how you're fixing your telescope, that go in there just as well.
Yeah.
I've got a little bit more to show if you're interested. This is a Peltier cell measurement I did of the front end. So you're seeing that. You're seeing a diagram.
Yeah. All good.
Okay, good. Well, there we go. That's the front end. As I mentioned, it's the original radio astronomy supplies circuit board mounted inside a new die-cast box, and I did all that fabrication work. It had to be customized, and I've confirmed it all electrically still works very satisfactorily again. But that die-cast box is then inside this larger plastic box, and then it's padded out with, as I mentioned, the foam insulation. And on top is this heat sink with a fan at one end to draw air in and then blow across the heat sink on the other side, the hot side of the Peltier cell. And we've got another member of the ASV who can do 3D printing, and he printed this beautiful plastic flange to go on the other end of the heat sink, so we can duct that heat away from the heat sink and outside into the open air beyond the feed point of the telescope. The low noise amplifier heat sink is that one sitting on the table next to it. It's not connected to anything. On the right-hand side of the front end box is this power supply box. So this is, again, the original components from the radio astronomy supplies repackaged up. I'll just try and zoom in on that if I can. Oh, something seized up there. So in that box there is the original power supply. The what do they call them? A boost converter. So they take, you could have 10 volts come in here, but you still get 12 volts out. And there's also a 5-volt regulator. And there's a couple of thermostat controllers for the Peltier cell. So each Peltier cell has its own temperature probe. And the original thermostat had an external relay, which we're still using, and an extra thermostat, which is going to switch the front end Peltier cell on and off, has a built-in relay on the circuit board. And down on the bottom left is that status monitor I talked about with the Arduino Nano and a couple of extra temperature sensor units. So let's cut to the chase and look at the graph. So I switched this system on, and I'd set the thermostat on the Peltier cell to 5 degrees C, 5 degrees centigrade. The blue line is the room ambient temperature, and that's measured by an independent temperature probe. The red line was the heat sink, right on the top of the heat sink on the hot side of the Peltier cell. That's the heat sink temperature. And the green line was the internal air using a platinum temperature probe inside the front end die-cast box, which is buried in all those other arrangements. And the green arrow there pointing to 5 degrees was where I set the thermostat. It turns out that thermostat, which is not as precise as the platinum probes, even though it was reading 5 degrees, the actual temperature, because I had a independent temperature probe sitting next to it, that was reading 7. So there's a 2-degree error that we have to account for. But you could see over 37 minutes from starting to zero time, 37 minutes there, the internal air cooled down to that 7 degrees, which is when the thermostat switched off. And you can see the heat sink on the other side get hot up to 37, nearly 38 degrees. And then you started seeing the cycling of the Peltier cell. The fan was running continuously all the time. But the thing that's important to us was the temperature differential between the room, the ambient temperature, and the internal air of the box. And that turns out to be only about 11 degrees. And I'm going to do some experiments where I push this process further, see how much lower I can get that internal temperature where you can still stabilize it. But that might only be dependent on the limits of that Peltier cell and its physical characteristics. They do have limitations. This particular one is like 36 watts. You might have to go to a 50-watt Peltier cell to make that extreme even further. But at the end of the day, you chase your tail, and there's a big consumption of power to get these things to do better than you expect. But we may not need it. I think it's important not to let that front end cook up to 40 degrees centigrade, but it may be satisfactory to have it run between, say, 15 degrees and 20, and have that as a range that we can manage for most of the year in our property up there at Heathcote, because it's all dependent on the atmospheric conditions and the environmental variations, which is Mother Nature, isn't it, Paul?
Certainly is, and yeah, we know we get extremes. I mean, this time of year it'd be pretty cold overnight there, but come summer we're looking at 40 degrees plus, and it's sitting out in the open, picking up every bit of radiation. And that green line, that 7 to 9, that's presumably just the hysteresis.
Yes,
The-
I set the hysteresis on the thermostat to be 1 degree. So it was
Yeah,
plus or
and that's
minus
exactly
1.
what you've got.
Yeah,
Yep.
it was exactly doing that.
Yeah.
Yep.
Very good.
Look, we won't get perfection. Sorry, go ahead, Bob.
Yeah, are you experiencing any moisture buildup or worried about moisture in there at all?
That's a very good question. I'm glad you did ask that. Let me see if I can bring up an image again. Oh, where are we? Oh, it was in that photograph, in an Excel spreadsheet in the setup. Oh, that doesn't really help you. Oh, look, I can, if I can zoom in on this image. Yes, I can. Okay. Let's share that again. Now, I think I might have been an advocate of this particular issue before. Now, once I open this up in, you're seeing that diagram again?
Yes.
Yeah, all good.
Once, for some reason, once it's opened up in Zoom, I can't physically zoom the spreadsheet. Well, every one of these boxes that I've fabricated here have got a gore vent on them. I've advocated this little product before, and this die-cast box is going to be an airtight seal. It's got electronics in it. I don't want to have that fail electronically or with moisture. So it's an airtight seal, and then you put this plastic gore vent in. There's a gore vent in the die-cast box of the front end, and then there's a gore vent in this plastic box. So there's an air path to equalize air pressure between the outside air and the inside air of the receiver front end. I can't move this around while it's on the screen. I don't know why that's the case. I'll just stop sharing it for a second. So all I can say is all of those boxes, each one of them have been ventilated. Even this, obviously the electronics microcontroller in the Arduino, you don't want moisture appearing on that because the conductors that are exposed there are very, very close together, and you muck that up and you've lost reliability or anything. That could just stop working. The clock could stop. So that's an airtight box again. All these connectors are airtight O-ring gasket sealed connectors, and there's a gore vent just down at the bottom of that box there. So they're airtight, and then you ventilate them. Seems counterintuitive, but the ventilation is through a Teflon membrane with micro pores in the membrane. So air goes through it easily, but liquid water can't. So you could have these things in driving rain and liquid water would never go through it. However, water vapor can. Now that would think, well, why water vapor could go in that box and condense out. But there's another thing that happens. Inside the box is warm. It's being heated by the electronics that are in there. So it's going to be slightly warmer than what's outside. And it's also a sales pitch from the suppliers of these gore vents, and they give visual demonstrations in little video clips on their website of how these things work. And the proof is in the pudding because the telecommunications industry use them everywhere, and they don't get failures. If you had unventilated boxes, you get failure in the electronics very, very quickly. And I'll show you a classic example of that in a moment. I'll just step aside and grab an item on the other side of the room here, and you'll be horrified to see the worst case scenario when you don't ventilate a box. When you don't ventilate a box, you've got a packet of air inside. It's stressed, and the seals, if you do have a seal on it, they're stressed and stressed and stressed continuously through the daily cycles of warm and cold, warm and cold. And eventually the seals fail, and that's when moisture gets drawn in and condenses out, and there's no mechanism to stop it. Just a moment, I'll grab this other item, and you'll be horrified to see the worst case of an unvented enclosure. Stand by.
While Steve's doing that, it's worth reflecting. I've got the same technology in my shoes, that Gore-Tex material that's in shoes. And the idea is that the rain can't get in, but it does ventilate your feet. So you've got exactly the same mechanism in shoes as Steve has in his containers there.
I'm back online. I've got a number of experiments running up at Heathcote, including a Whistler receiver. You might be familiar with the VLF Whistler receiver. And I've been maintaining that particular die-cast box for several years now. And occasionally I'll open it up and it's dry as toast. And it looks like the day I built it. So this is a neutral hydrogen low noise amplifier. It was part of a system that we're going to restore and build up at Heathcote, which was an interferometer neutral hydrogen receiver. So this is one of the LNAs. There's two of them for each of the antennas. And so that looks reasonable on the outside, a bit of exposure in some of the copper surfaces, the aluminium surfaces, but have a look at what it's like inside. It's aluminium oxide everywhere. It's white and mucky and horrible. And the same applies to the circuit board of the actual low noise amplifier. It's in real disarray there. I think it might be recoverable. I'm going to do my best to clean up the circuit. But you can see the seals, the O-ring seals that were originally in the box have disintegrated. And that's one of the consequences of there's no ventilation in this one. It was assumed that you seal it up airtight, put it out in the weather and it's going to survive. They simply do not.
Very good. Any questions, any thoughts from around?
I
like to
have,
make go ahead.
oh, sorry. I have two questions. The first
Yep.
question is, when Steve completes his report, I hope that we can have access to the whole report and lots of pictures. I
Sure
think
thing.
that would be, is that a possibility?
And that's for the evaluation of the Peltier cells with the repackaging of our receiver. Is that what you're talking about?
Yes, just everything.
All that
And-
thermal evaluation. Yeah, sure.
And also, I know that you've given some thought to how to keep the degradation of the jack screw at bay. If it's possible to share some of that information.
Oh, okay. I didn't mention that. Yes, as part of the fixing of the worn out parts.
And also to prevent the corrosion. I mean, I know you've thought about it and probably addressed it.
No, not yet. Not today anyway. And we neglected this particular problem for a number of years. We let the jack screw that's lifting up the dish up and down, we let that in the weather for several years, which was a big mistake. And what we're planning to do, either side of the gearbox where the worm drive is, both sides of that jack screw is going to have a protective cover over it. They're called bellows. So they look like a concertina. When the two parts come together, they'll have to compress up with like multiple layers. As they stretch out, they'll have to stretch. So it'd be like a concertina, and there'll be one on each side of the gearbox, and they'll have to be, again, sealed up, watertight, so we don't get rain onto the jack screw. And the jack screw will be well and truly greased, and we'll have to go through a regular maintenance program. We just schedule it every 6 months or every 3 months and be diligent about it. That's where the problem came in. As a bunch of volunteers and amateurs, we've neglected this too long. We can't do it anymore. To fit, as this bellows start to come down, they'll get fatter and wider. And there was a clash when it got close to the metalwork of the two scissor plates that lift the fixed plate and the one that moves the dish up and down. So we had to have a piece cut out of the fixed plate. And that was I can show that on screen. I can share that image on screen. So in that image, you're seeing an aerial view looking down the tower. That's the 1 meter diameter steel tower, and there's our concrete base at the bottom. And there's the fixed plate. And we've got a lot of the parts removed, of course. And in that area there, we've had this piece cut out, this large arc, 400 millimeters diameter, 50 mil thick steel plate was cut away. contractors went up to our property. We had a scaffold erected prior to them arriving. So they just had to climb up there and get their cutting equipment in place and cut that piece out. So that was a couple of $1,000 Australian to do that work on its own. So this is no small effort.
Steve, you were saying that the bronze bulk material was going to be $800 or $900. You might want to just try going down to some marina or shipyard and see if they have a broken propeller that you could cut.
Oh, really?
A piece of bronze out of something that's broken.
Look, it's a good suggestion, Alex. We're always looking for cost-effective ways to do things. What could be the danger with that is the quality of the phosphor bronze. You just don't know, do you? You don't know its history. You don't know the chemical mixture. You don't maybe have to do a chemical analysis. It's really got to match up with what we have there already. And I think Greg Walton, who's going to do the work, he knows what the material needed to be, and he's sourced a supplier up in New South Wales, the city of Sydney. Yeah, look, it's a good point. I'll suggest it to him. See what he thinks.
I think if you pay your $900, Steve, and you know what you're getting, then I guess that makes it easier. 900 is better than 7,000.
When you saw that angle grinder cut through the jack screw, that's a hardened steel, very, very tough hardened steel. There's no sign of wear anywhere along the length of that jack screw throughout its couple of years use already. So that's the hard part. The phosphor bronze is the sacrificial part. That's the bit you're going to get wear anyway. You can't have a gear system like this where they're both hard. I think there's a mechanical reason for that. I'm not a mechanical expert, but you've got to have one part that is sacrificial. And the only way to minimize wear is that constant lubrication.
Very good. Thank you, Steve. And yeah,
pleasure.
I'll encourage Steve to submit something for the journal so that we can.
Well, Steve, can I make a comment?
Go ahead, Rob.
Steve, you showed the electronics with all the oxidation on it. What you might consider doing is coating your electronics with epoxy. And the epoxy will keep the moisture from, the epoxy will keep, the moisture from attacking, your circuitry. And the next thing is.
That's a good suggestion, Rob. Have you done it?
Oh, yes, I have.
Oh, gosh. Okay. It's kind of it's the last time you'll ever see the circuit, though, isn't it? And it's also unserviceable after that.
Well, not really. There are ways of doing it.
Yeah.
But if you've done a good job in the first place, you won't have to.
Okay.
And the next thing is, what you want to do is in the side of your box is install a rubber bung and use dry nitrogen to fill up the inside of it. And the bung will expand and contract with the temperature change.
That is absolutely another alternative, Rob. An alternative to the gore vent. And I agree with you there. It's something I've never tried. And yeah, look.
It will work.
Getting access to dry nitrogen.
But you can get it at the gas. I think Costco has dry nitrogen. They fill up your tires with it.
That's true.
Okay.
And if you want references as to why I think that's a good idea, I can give them to you.
Okay. Yeah, look, nitrogen is certainly the way to go. That's a solution. Obviously, when you don't have any water vapor, you can't have water condense, can you?
And the reason for that is you're installing foam inside. If you don't have airflow, the components won't cool down. And
my biggest concern, if you didn't put epoxy on, so epoxy is a good idea, but if you seal this up, even with nitrogen in there, if you seal it up airtight, there is still going to be that problem of stress on your
That's
seals.
the rubber bung. That's the rubber bung.
Yeah.
You put this rubber bung in, and that expands and contracts.
Okay. Good point, Rob. Another option.
And if you really want to measure the temperature of your electronics, measure the resistance of the Schottky barrier diode on the input to one of your semiconductors, and you can actually measure the substrate.
Amazing. I love
And if
all
you
these
want-
alternatives. Yeah.
And if you want references to all of that, I can provide them.
Great stuff.
That'd be great. Thank you, Rob. Any other comments around? Yeah, it says DCW. I'm not sure who. Go
No
ahead.
sound. No sound. No voice.
Yeah, got you now. Are you there? We've got you. DCW.
I'm not sure I'm DCW. This is Jim. I'm also an engineer. And the last comments I heard, I totally agree with. However, I guess being an engineer, I'm new to this whole thing. I'm just signing in for the first time. And is the goal to do a complete restore of what exists with no changes? I'm just curious from a big picture. I have a couple comments.
James, our group, the ASV, the Astronomical Society of Victoria, we purchased a neutral hydrogen receiver several years ago from radio astronomy suppliers in the US. And ostensibly, it's a good product. It's a good design. There were a number of electromechanical aspects of it that we found that, were less than desirable. So we've repackaged the circuitry, repackaged it, and made it into a situation where we can manage the temperature stability of that receiver quite a lot better. And so we're in the process of finishing that repackaging arrangement, and it'll be reinstalled on our dish, hopefully in the spring, our spring, and we'll start our neutral hydrogen survey. Now, this is all old hat for a lot of you guys. I know you've all done neutral hydrogen. You've probably got the results and that's it. You want to move on. But for us, it's still the beginning. We've still got a lot to learn. And we're still keen to get our results with our telescope on our sky.
Yeah, great. I guess just a couple comments relative to maybe some inputs. Doing a restore is essentially that can actually be more difficult than starting over in some cases, as long as it fits in the box that you're trying to fit it in. Just a comment. The other comment, have you heard of a Hilch vortex cooling system? I don't know if you've heard of this, or a small refrigerator system. I guess I don't know what goals you're shooting for, but there are some lab type cooling systems based on Hilch vortex. I know you're trying to do an exact, replacement of what's already there. However, some of these lab cooling systems are very small, and a Peltier system, I played with them, and you really can't get that much delta. I guess there's two things you're probably trying to do: is get it to be a wide delta, and you're also trying to get it very stable. I just threw out a comment. If you've heard of a Hilch vortex, it might be worth looking into.
Yeah, I understand what you mean by Peltier cells. They do have a limit in the delta. There's no question of that. And at the end of the day, it's a question of whether that's the delta that we do achieve is suitable. It's better than nothing. So, at the ambient temperature at our country property can vary between -4 and +40. So if you can squeeze that down, you're in a better position. Yeah. So the Peltier cell is going to give you some of that, not all of it, but some of it. And one part that we won't get is if you set, say, the Peltier cell to 15 degrees centigrade, when it gets colder, it's going to go down and follow it as it gets colder. But that's, I think, a lot better than let it drifting up to 40 degrees. So we're going to narrow the variation, minimize the amount of drift, and then we'll compensate for it by this noise reference that we can always go back and calibrate against that.
Very good. Yeah, thank you.
The refrigeration, it's all got to fit up on the feed point. So if we put a refrigerator up there, it's another lump of mass. We can put probably another 20 or 30 kilos up there, but it's got to be powered. So at the moment, we're only running DC low voltage, 12 volts up to the feed point. So is this refrigerator system, James, is that a AC powered main system?
Okay, it's very interesting. It's called a Hilch vortex. It's based on air pressure. Okay, and if you can get a pressurized hose to this vortex system. And what it does is it's kind of it circulates the air in with a smaller orifice on one side and a larger on the other side. What it does, it separates the heat, and you can get some small ones. I know there are some laboratory things that are quite small. I just threw it out there as maybe an alternative. I guess
That's a heat pump. Basically,
yeah,
it's a heat pump.
It's a pump. Yeah.
Okay.
Yeah. And they're small. You can get laboratory versions of it, but I fooled with the Peltier thing, and for small changes, it's probably pretty good. Now the wide changes, you may have to play with a little bit.
Okay.
Yeah. Anyway.
A
Thanks,
vortex.
Jim.
Hill's vortex.
Steve, there's a question in the chat about the lifting and falling motor currents on your lead screw system. Do you have any idea what they are?
No. Look, it's a highly geared system, so we've never seen it. It's been mechanically engineered too by a professional firm that did all the calculations. So that part of it, the drive system, I haven't been involved in it, not being a mechanical engineer, but it was thoroughly evaluated, analysed, and designed. And I don't know the forces involved, Paul, but it never seems to, it doesn't seem to grind and slow down and change speed as it goes through the motion. It seems to be a continuous, well-driven system.
Yeah. Okay, I think
hope that answers the question.
Yep. Good stuff there. I think and real progress being made. Thanks, Steve, for all of that. We might come back to you later in the session. I was interested, Rob, do you have anything from your end, an update? What have you been up to?
But what I've been doing is, my dome is partially constructed. And what I've been doing is coming up with a technique to put a compass on the dome so I can have the dome track the actual, aperture of my telescope. And I've also, designed a weather station to put on this thing, as well as the solar panels and all those two bells and whistles. Okay. And I've also, made progress on my meteor camera, to see what's going on with that. Outside of that, nothing really new to report.
Okay, well, we'll perhaps get a report from you in future months as you make progress. Now, do we have any other Australians? I've got names, but I'm not. I think is that we've covered everybody from this end. I think everyone's at your end. Everyone else is at your end, Rich. Because we've got a few missing. So DCW, I'm sorry, I'm not quite sure who you are. Is there a problem? I think you might have a problem with sound. Is that right? Yeah. If put it in the chat, and then so we know a name, and I can put you on my list. It sounds, Rich, it sounds like we've got a problem with sound there. So I think we might hand back to you and see if you got reports from your end.
All right.
I see the chat talks about Duncan Campbell Wilson.
Right, okay.
So we have a name. Thanks, Duncan.
Okay. And Ted's got an update on the shoes survey. So go ahead, Ted.
I think I'm ready to embarrass myself here.
All right.
We're going to try some new technology. There are 2 Ted Cline signed on, and so I'm going to share from Ted Cline number 2 here and see if we can make this happen. We talked about shoes and somehow sharing. Oh, I see. My chat's in the way. Move him out of the way, and then I think you'll see a better screen. All right, we're seeing everything. I need to go to Zoom. So you're going to see, oh, I fell out of Zoom. How? I'm sharing. No, I don't want to join. I'm already here.
You're sharing the desktop.
Yeah, I see that. Because I'm monitoring myself. I thought I could see the Zoom page just like I do on my screen. All right, well, I can't do that part. Let's see. then we'll do it a different way. In the chat, I have no way to get it over here though. I was going to use chat to get it. So if I sign out, no, yeah, then I could grab it. All right. The embarrassment has begun here. Hang on. I'm going to stop sharing so I can see the world. And I'm going to have the regular Ted Cline talk here and put in a chat. All right. I claim that this link will get you started on shoes. So here this comes. It's a beaut. You can go ahead and try to pronounce that. Oh, I see. And someone, Steve, posted just after me. Very good. So now Ted Cline 2 is going to be just like you and link on that. Click on that link is my hope. Yeah. Okay, good. That's fine. I'm getting authorization and pulling up my browser because of that link. The system we have right now is temporary, and I have no way to host a web page. Apparently Google Drive doesn't do it, and apparently Dropbox doesn't do it, and we haven't quite got it tied into Sarah yet, so we're trying. And I think I'm pulling all this up. I think a browser's coming up here for Ted Cline 2. So that I can now share that screen with my thought. Oh, brother. Okay, well, we'll have to just grab it. I'm hoping I could click on it, but now I'm going to have to do a copy and paste. And that's impossible. I can't get out of here.
Just say hi to Roger, who's just appeared. Just while Ted's getting sorted. Roger, will you have anything to report, or are you just observing?
Yeah, just observing. Sorry, a bit late. I thought it was actually next weekend, so I just jumped in then. But I've had a couple of things have turned up. My Radio Joe system's turned up. Unfortunately, I haven't had time to actually do anything with it yet. One of the insulators was broken in it, so I'm not going to be able to get it quite up to its full speed straight away, but I'm onto it. Don't know what else really. Yeah, the SDR that came with it seems to be able to do what I want it to do. Yep. So next week, I've got to say this week's the solstice. I've been fiddling around with the sundial, so that's been keeping me busy. I could probably put a picture of my sundial up, maybe.
Yeah, I'd be interested in that. That's a project I've got going at school on the sundial side.
The main reason I've done it is my property has the 150 degrees of longitude goes through the front paddock. So I've actually set it up on that, 10 hours ahead of universal time. So it should be pretty accurate, really, if I, once I actually get it lined up properly. It's the idea anyway.
145 runs through my property.
Yeah, okay.
I'm exactly on 145.
Yeah. So anyway,
Ted, how are we going? Sorry, Roger.
Yeah, as I say, seeing as it's the whole Eastern time zone's based around that particular line, I thought it was a good thing to do. Anyway, so that's been my excuse for not quite getting my Radio Joe system working. Next month.
So we'll come back to you, Roger. So I have something ready on the sundial. Ted, are we ready?
We're going to find out here. That's good. All right, Ted Cline 2 is not working. We're going to try Ted Cline 1 here, pardon me. And on this Zoom, can I now find the right page to share with you? Yeah, that looks close.
It's good to have you here twice, Ted.
Maybe. All right. You should now be seeing a pretty white screen that says shoes in the top left-hand corner.
Yep, got it.
Wonderful. I clicked on that link, and this is the page that came up. You can see that this is not the normal hosting of a web page, but it looks like HTML. So what I'm suggesting you do is get the file this way and then put it on your local machine. I'm going to demo that here. I can go to the top right and click on download, and that brings down a little file. I'm not sure if you see it on your world.
Yeah,
Shoes down on the bottom. And if I click on that now my local PC is hosting the web page, and you can see that now, I hope.
I'm following the steps here as
And
well.
then we finally get to a web page in a complicated process instead of in one step.
Yep.
Here's the web page. This is as much as it is. I've populated with a couple of examples of some data, and you can get the same places I did with that one link. That's the idea with this two-step process. It's got a couple of links at the top and a couple of titles, but the excitement's down here where the databases are. These are the big files over here on the left. You click them and you actually get it. We'll give you a demonstration here in a moment. In Rich's backyard, I think you'll see this, or does it pop up a new window? Do you see a dish?
Yep, 10 foot.
Okay, so we're saving on the same screen.
Yep.
Very good. That's Rich's disk. If I do this now, yeah, we should be back to the white screen. Yes.
Yep.
And so some of these links actually show what you're getting the data from. These are some locations over here, and they're mostly just maps. But down in here, we can start looking to see a right ascension declination image of where the data is coming from. Let me do this top one here and click on it. And hopefully we see a picture coming down from above. The green dots are where the data was actually collected from, right along the galactic plane. So this must be LTO 15 that has motors on it, and I can control exactly what data we're tracking in the sky. Another example is a drift scan example from the LTO 16, the next line down, and we can see lots of drift scans along here. This is a vertical offset plot, so the little bumps indicate just a little bit more energy in that location. And so indeed, if I do a Control W and make that go away, that's what these two links represent. And down here, there's some other very simple one-day drift scans to experiment with. Those, of course, are the nice small ones, one megabyte, 2 megabytes. The motored one was 9 megabytes, but beware of this one. This is 1.3 gigabytes.
Yep.
One of my systems was talking about 30 minutes to download that one. And then Rich has another example up here, and that's for the Spectra Cyber. And it kind of came out like this for that one day. So this is what's possible real quickly for collecting some or grabbing some data and playing with it, or putting yours up here as well. I hope that's helpful. Any questions?
I was following that, Ted, and I've done exactly the same on my screen. So your link is working okay.
That's encouraging. Okay,
Yep.
Excellent.
So,
If that's helpful, I hope it is. That's all.
How long to obtain a full sky scan? 12
24
months?
hours?
Well, okay. A full sky scan. I'm going to click on the big one here for a picture. This was about 6 months because I ran each drift scan for 7 days or so, and I'm sure there were bad weather, so I skipped some. That's about 3 degrees apart.
Yep, good.
That's a start anyway. But with a motor, of course, it goes much quicker. I chose to, since I don't know what it should be, I chose to go 15 minutes on one data point at a time. But now that you have motors, you don't have all this empty space you're wasting time on.
Yep. Although that empty space may still contain something interesting.
Yes. And in fact, that's the database I'm using to start studying the 3D characteristics of galactic arms.
Yep.
I have a new video out on Ezra that's up on the Sarah webpage, the YouTube webpage, and of course on my Ezra webpage, which is one of these clicks down here, for a quick introduction down here in all these videos. Simple overview might be helpful.
Mm-hmm.
Other questions? Very good. I'll probably put a post in the Sarah listserv for this information as well.
Yep.
So Ted and I had a discussion of, where Sarah sells a what we call a scope in the box hydrogen system that has an RTL SDR receiver using the SDR Sharp software. If you collect the data with that, it comes up with one set of files, I guess multiple files. I guess the option is that if you use the Ezra, is it Ezra Call, I think, Ted? Software.
Easy call for collect.
Easy call with the same hardware. That produces a different kind of set of file, or different data set. But either one can be loaded on this and made available, and you can process the data and basically produce those pictures that Ted has in the rest of his videos. And I think that's sort of one of the lessons learned of doing this hydrogen stuff is, if you do have data, I mean, what are you going to do with it, and how do you produce the pictures of the galaxy, things like that? That's after you collect the data. Then there's the part of collecting the data. So I think what I'd recommend is that, some people are working on getting the telescopes working and the receivers working, but the other people that don't have the telescopes, they should grab some of this data and try to learn the software and producing the pictures and analyzing the data that will be collected from your systems. It was like Ted sort of showing on his screen there. And Ted, I don't know if you want to go over that real quick, what you're showing on your little mini screen. You show that up on the, just share that.
I'm thinking that's all covered in the videos. I'm not going to go through it here. Look at that introductory simple overview for a good start.
Yeah.
I don't mean to push it too hard. This is just one alternative. Let's improve it to even better.
And if people do collect data, I think we put down where they send it so that we can get it put on and shared it with everybody else.
The first step is my email is at the bottom of that page, and it's on the Ezra page, and here I am. So come talk to me and be a pioneer. We'll try to figure out how to do this.
And note, we are missing the Southern Hemisphere version of that data. So the sooner we can get some of that help fill it in. Okay.
Please be patient a little bit longer.
Oh no, that's fine. And I'm saying some of your guys might have a smaller dish that I think we're looking at. If you just take a dish and you look straight up and collect a couple days worth of data looking straight up from your location, and then send it in, that would be very valuable, and it'll help figure out if your system, what your system's collecting and the data quality, and we can work with that, and then we can work on getting the different angles and stuff like that for different elevations. But I would say if anybody has just a hydrogen dish that they just want to look straight up from their location and collect 2 or 3 days worth of drift scan, that'd be perfect.
One of the things we can do, I mentioned this interferometer that we're building. There's 2 dishes there, so we could just take one of those and collect data with that.
I think that'd be great, and then we can collect the data. We can even convert the time and the location to right ascension declination automatically, and then we load it, and then you can use it.
Yep.
And as I'm saying, big dishes aren't necessarily the best for hydrogen collection because they're a soda straw. A smaller dish that has a little wider beam width might actually be better for hydrogen collection. It gives you a little broader picture of the sky. So, all right.
Good point.
So yeah, we'll take that if you want to try that. That'd be great, and that'll get your system. You'll get your software and your receivers all working before your big dish, your pointing dish gets up online. Okay.
Sorry, it's Rich. It strikes me also that Victorian Space Science Education Centre has its dish up not that far away from Heathcote, where ours is, and I might talk to them and see if they can provide us with some data as well. I think they have government schools, so kids in government schools collecting data, and I think it would be a really good STEM project for them to be actually contributing to an international database for mapping the galaxy. So I'll have a word with them.
Great. Great. That'd be excellent. Okay. Is that it?
That's it for me, pretty much.
All right. Thank you. Jade, you got anything else? Eastern Conference or anything else?
Nothing else to add other than for people who are interested in participating virtually, we've tried to reduce the cost as much as possible, and the registration cost is only $15 US. So we hope that'll encourage as many people as possible to participate.
Yeah, you'll get mine today, Jay. And Rich, I'll renew my membership. So I've got it on my machine all ready to go.
All right, great. And don't forget the stuff you guys are doing. We have a lot of journal articles on how it took someone to build a radio telescope or to repair a radio telescope, and those are all very useful things for put in the journal. So we'll take that. If you guys got it all documented, just put a couple words together and put it into a Word file and ship it to me, and I'll put it in the next journal, because I think this is very valuable to document on what problems you guys had with worm gears, because someone else is going to have a problem in the future with worm gears. They could look it up, what you did.
Also, if I can say, Rich has made an excellent indexing system. So if you're looking for something, now you have a chance of finding it.
Yeah, we got almost 40 years worth of journal articles that we've got in Excel documentation. So thanks for reminding me, Wendy. I got to update that for the last journal. So
you're doing better than anybody else did, which was, I believe, nothing.
Yeah. Well, good. Thank you. Okay. Alex, you got any updates you want to give?
No, just stopped in to sort of see what was going on. I don't have any inputs this evening.
I think if you guys haven't looked at Alex's video on umbrella antennas, very good STEM projects can be done with that. Having the kids making it basically close to a parabolic dish with an umbrella. I think that'd be very good.
That's my next challenge. Once I get the sundial out of the way.
Let's see, Steve. Wendy, did you have anything else? I got you on the list.
Oh no, I got nothing. I just enjoy listening to all of this.
Okay. Bob.
Yeah, I wanted to check in and say hello to the people in Australia. I've watched all the YouTube videos of the previous conferences and really enjoyed hearing from you folks and seeing some of your work that you're doing down there, and it's encouraging. I've got a small ranch here in Texas, and kind of gradually, slowly working towards installing various data collection systems myself. I spent a big part of the day today setting up a cabinet sort of a thing I'm building and putting out in a pasture. I've got a couple of them now strategically located so I can put some antennas around them, and I've got power and network to them so I can collect data back from them. And so I got this one mounted today, and I'm pretty excited about it because now I can move on to actually getting something to collect data from them. I do have a Meteor camera that worked for about 3 or 4 months and was passing data back into the global Meteor network. And that was fun, but rain finally got to that moisture, and so I had to rebuild that. And ever since I took it down, when I put it back up, I have some kind of an issue or another, and eventually I'll have that working again, and hope to have 2 of those looking in 2 different directions soon. But anyway, just kind of wanted to check in and say hello. Back to you, Rich.
All right, great. Any questions for Bob?
I think I saw some pictures. Were there pictures in the journal of your cabinets? I came across your pictures somewhere.
I posted a note or 2 on one of these sessions that might have got picked up on a YouTube.
Looked very good. Nice to have some space.
Yeah,
put them up.
It is.
All right. I see a James Doyle. I don't know if did we talk to him yet, Paul?
Not sure. James? No, just an image.
Yeah. James, you got anything?
He might be off having coffee.
And also, it looks as if DCW is VK3 Delta Charlie Whiskey.
VK5.
Ah, you're right. VK5.
VK5. Yeah. And Duncan, if you could put an email address in the chat for us. I don't have an email address for you. That would be helpful. I looked up on QRZ, but you're not there for some reason. Hidden away. But if you, Roger, did you find a picture of your sundial?
Yeah, I did. First try for me to try and share something. I assume I use share screen. Here we go.
Screen. That's the clue.
Now I've just got to find it. Hang on. Let's have a look here. Files. Just right. Okay. Well, here we go. There's one on Facebook. So do I just drag and drop them into here? How do I do this? Anyone got any ideas?
That's
not going to work.
It says share screen, and it should just show little.
Have what you want to show us on your desktop.
Put it on
when
your,
you go,
bring it up first, and then share the desktop.
Yep.
Okay, so I've now got a picture up here. So
we're not seeing it yet.
Oh, I see. Hang on. Share desktop. Yeah. So I reckon if I click on that one here, that one. You see that?
Yeah, we're seeing a photo.
Yep.
There you go. So that's it. It's basically an 8 meter long piece of 75 by 120 mil steel with 75 mil RHS legs on it. So it's angled at 32.7 degrees, which is my latitude here, and it's got up on the top of it, it's got a hole, just a sight on the end of it, so that you can trace the light patch as it comes along the ground. So at the moment, I've just got it pegged down with star droppers, so I intend sort of lining it up a little bit better at some stage, but at the moment it's up there and it hasn't fallen over, so that's been pretty good. So I'm just knocking pegs in the ground at the moment, so I intend letting it do the figure 8 thing on the ground. The other thing I intend doing is putting some at the bottom end here, some radial lines on it to line up with Alpha Centauri. Alpha Centauri is, the first brightest thing in the southern sky that comes up in that area. So from that, I should be able to have a different one for each month of the year, or each zodiac sign or something like that, so that you can actually tell what month of the year it is from that. And then next day, go back to the sundial part of it and get an accurate time measurement. So basically should be able to sort out what time of year it is and exactly what time it is at midday. So I set it up the other day because of the solstice. So I should now have got the furthest southern peg in the ground. And so over the next couple of months, I'll just trace it with pegs in the ground to see where it goes, and then sort of pull it all apart again and set it all up properly down the track a bit. So I do actually have another one here.
Looks like a stick. Looks like a stick figure of a dinosaur, Roger.
Yeah, it does.
Yeah,
It's gorgeous.
pterodactyl, I call it. Like a pterodactyl. Everyone, it looks a bit like a giraffe too. So anyway, it's got plenty of animals you can put into it. But I'm hoping it's actually going to be quite a practical thing.
Yeah,
anyway,
nice.
on the solstice night, just in front of it down here, we had a bonfire. So it's been, what's the word? Christened with a bonfire and alcohol.
Did you
so
dance
that's- as I
around
say, that's what
naked
I've
as
been-
well? Is that something you do on the solstice?
Well, yeah, I hope so. I'm hoping next year. It actually rained this year. It would have been a bit cold, but you just never know. Next year we find a slaughter a few goats, a few virgins, that sort of stuff.
There's a
why
bunch
not?
that run naked into the sea down there, isn't there?
Yeah, I suppose so. That's a long way from the sea here, though.
Okay.
Anyway,
But
that's been my
also-
little project.
You can also use it to get a true north heading, I guess, too, by knowing exactly when to look at
Yeah,
it.
well, south here. So it points at the south. So the way I'll set it up eventually is just with a camera. I'll set a camera up along the length of the main the gnomon part, and just center it on the star circles. So I'll eventually get adjustments on the legs so that I can push it into the right position, so that I can, as I say, I'll center it on star circles. Just take long exposures, looking along the length of the thing until I can get it centered on the circles. That's the plan, anyway. So hopefully, at least in the next few weeks, I'll start getting the camera part of it organised.
Great stuff. Yeah, good. Nice piece of engineering. I'll just share this screen. I think you can see that. This is the one. This
Okay.
is the style of sundial we're going to build at school. This is not the actual one, but in this case, the person is the gnomon. So the person casts the shadow, and you have to stand at different places depending on time of year. Short shadows in summer, like this. Longer shadows in winter, you've got to stand further back. And then the hour markers around like that. So another approach to building such things. Not strictly radio astronomy, Rich, but good fun.
all
Well, I
this
got
stuff
you, Rich.
is,
So I had a little bit. I joined the association this month as well, but there seemed to be a little bit of a mix-up with the payment for the sun system. What is it? I bought one of your
Super
SIDs.
SID.
Yeah, Super SID. And there seemed to be a bit of a mix-up with the postage on it. So I think I may actually owe you some money. So if you do, just send me an email. I just went through the click on the things through the website, and it seemed to have shortchanged you a bit. I'm not quite sure how. I went back into it to see if I could work it out, but I couldn't even find the amount of money that I did eventually pay. It wasn't on the website anymore. So something weird's happened there. Not quite sure. But as I say, if I owe you money, let us know. I'll send it to you.
I'm sure we'll figure it out. Not a problem.
Okay.
Just let us know. Just let us know how it works.
Yeah. Okay. It hasn't arrived yet. So hopefully by next month I'll be able to let you know. Great.
And okay. Let's see. I think Tom, you're the last one on my list. He's there.
Hello,
Yeah.
Rich. I guess I'll say good day to everyone since I'm not sure whether it's morning or evening. I just actually had a chance to get in here, so I just thought I'd log on, see in, and listen in, and I have nothing else to report. But it's been a good discussion.
All right. Thanks, Tom. All right, Paul, I think that's all we got.
I think that's it. That's we've covered everybody, and we'll hope for some of the others. We might get Andrew back next month. I think he said he would be back with us. He's usually got something to report from Tasmania.
Yeah.
Unless his employer sends him off to the Antarctic again, in which case might slow him down.
All right. Well, thanks everybody, and I think that's it.
Yep. All right. Thanks everybody.
Yeah, appreciate the feedback and the tips, the advice. Thank you.
Bye all.